Hello. In this video we will learn about what a force is and how we can use it. Whenever two objects interact with each other, they exert forces on each other. In fact, that is pretty much the definition of interacting in physics. Bob can push Jill. That means Bob exerts a force on Jill away from himself. Or Jill can pull Bob. That means Jill exerts a force on Bob towards herself. They can also collide with each other, and in that case there is some kind of complicated mixture of forces between the two of them. When an object feels a force, it changes the way it is currently moving. So when Jill is standing still and then gets pushed, she begins moving away from Bob. In other words, her velocity has changed from the push, which means that she has accelerated. So the whole idea is that a force is what causes an acceleration. Way back in 1686, Isaac Newton formulated 3 laws of motion. These 3 laws kick-started the development of physics, and they form the basis for everything we will be doing in this course. The first law states that if no forces act on an object, its velocity will not change. As we just mentioned before, a force causes an acceleration, and if there is no force, then there is no acceleration. Without acceleration, the velocity won't change. The way you will often hear this law formulated is, an object at rest stays at rest, and an object in motion stays in motion, unless there is some outside force that is acting upon it. So, whenever you kick a soccer ball, it will move, but then you see it slow to a halt. That means that there is some force, which we call friction, that slows the ball down. If there wasn't some friction force, then it would keep rolling forever. Indeed, in space, where there is no friction, an object sent into motion might keep drifting for eternity, since there is no force to stop it. Now, what if there is a force pulling a ball to the right, but there is also an equal force pulling the ball to the left? Do you think the ball will accelerate? Whenever there are multiple forces acting on an object, we simply add them together. In this case, since the two forces are equal but in opposite directions, they sum to 0. So in this case, there are forces acting on the object, but they cancel each other out. Therefore, the object does not accelerate. So we should add something to our first law. If the sum of vectors acting on an object is 0, then it will not change its velocity. So great, we know that force causes an acceleration, but it would be nice to have the relationship between a force and the acceleration that it causes. Thankfully, Newton has a second law, and it states force equals the mass times the acceleration. This is often written as F equals ma. I like to rearrange this as acceleration equals force divided by the mass. Mass is a property that all objects have. The most helpful way of thinking about mass is seen from this formula. The larger the mass, the smaller the acceleration. So, the more mass an object has, the more difficult it is to make it accelerate. So you could say that mass resists acceleration. Here on Earth, you can get a sense of how massive an object is simply by picking it up. The more massive an object, the heavier it will feel. So, on Earth at least, you can think of mass and weight as closely related. The unit of mass we will use is a kilogram, which is 1,000 grams. Kilo means 1,000. As before, this formula could use a small correction. The acceleration is really the sum of all forces divided by the mass. That symbol there is a Greek sigma, which is often used to mean the sum. Just like any physical quantity, force has a unit of measurement. In this course we will use the Newton, named after Isaac Newton. The Newton is actually a combination of other units. It is a kilogram multiplied by meter per second squared, which makes sense since force equals mass times acceleration, and the unit of mass is a kilogram, while the unit of acceleration is meter per second squared. So let's look at an example. Imagine there is a plane that has a mass of 500 kilograms trying to reach a certain altitude, so its engines are outputting a certain force vector upward and to the right. However, the wind is not cooperating, and it's pushing downward and to the left with a force vector. What will the acceleration vector of the plane be? Go ahead, try to work this out yourself. So, to get the acceleration, we use this formula that we talked about. The first step then is to write the sum of forces. In this case, we have to add together our two force vectors, which is simply vector addition. To get the x component, we add together 800 and negative 200, and we get 600 newtons. To get the y component, we add together the 300 newtons with the negative 100 newtons, and get 200 newtons. So we have a net force vector of 600, 200 newtons. We then divide this by the mass, which is 500 kilograms. Now 600 newtons divided by 500 kilograms is 1.2 meter per second squared. because again, a newton is kilogram times meters per second squared. So dividing by kilogram just leaves the meter per second squared. Similarly, 200 divided by 500 kilograms is 0.4 meter per second squared. So our acceleration vector is 1.2, 0.4 meter per second squared. So let's summarize. A force causes the acceleration of an object according to the formula net force equals mass times acceleration. When the force is equal to 0, then the object won't accelerate, which means its velocity will stay the same. That's really all you need to know.